Hey guys, welcome back. We're going to talk through a one sample t-test for mu. Okay, so this is when we're going to have data. And so this is when we're not going to have p for my h sub o. I'm going to have mu, 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 mu. And this is when I'm not going to have my test statistic is not going to have little p hats and p's in it. My test statistic is going to have x bars and mu's in it. And it's not going to have a z, it's going to have a t. Okay, so that's kind of the difference between the two. Now, the same is these conclusions, and mostly the plans are the same, and these are somewhat the same. There's a slight nuance between the two, so let's do it. Okay, humerus bones from the same sample species tend to have animals approximately the same length to which ratios. We collected these bones and discovered that species of animals had these ratios. It's known these species to be called Mollichimus primatium, exhibiting this mean ratio. Suppose that 41, so this is our accepted truth, our h sub o. Our h sub o is that mu should be 8.9. Suppose 41, so that's our n. 41 of these bones were unearthed, and the researchers are willing to, random, that's good, of all such humerus bones, they were calculated. Test whether the population mean for these species differs from. So like we said last time, going back to our notes, if it just merely differs from, then we're kind of have to pick it. This is called a two-sided test. If they think it, if there's sneaky suspicion it's greater, we pick this. If our sneaky suspicion it's something less than, we pick that. Less than or lesser. Okay. So let's take a look. First, we must put all the data in, and these are humerus bones. So I'm just going to call this bones. Okay, and then I'm going to start typing them all in. So I would suggest in a new order, but maybe one column at a time. Ooh, looks like I'd already used the word bones. So it wanted to know if I overwrote the data. Okay, so that's why I'm always careful kind of being a little creative. I'm going to call bones H because they're humerus bones. Okay, so let's look at this data again. I'm going to give this another try. 9.73, enter. Okay, let's hope all those are correct. I am going to double check. So 9299999 957 886 1002 893 871 935 818 814 948 666 989 956 941 917 984 623 989 852 939 938 998 887 917 984. Okay, that's looking good. 12, 913, 852, 939, 1039, 37, 807, 1173, 907, 83, 1048. Yep. 783, 907. Okay, those are good. So we're going to go to menu. We're going to go to stats. We're going to perform a t-test, my friends, and we have data. So we're going to hit enter. What is our mu naught? Well, we said our accepted truth would be 8.9. Okay. What is my list called? My list is called Bones H. I renamed it Bones H. Now, I got to think about my sneaky suspicion. It says the word, I underline the word just that it differs from that. So that would have to be this two-sided test. Okay, and now I'm going to hit enter. So let's take a look. Get out all our steps. So state. We will perform a one sample t-test. Again, remember we're stating the parameter and what we're interested in test. One sample t-test per meal. Okay. Our H sub O is that mu is 8.9. And our H sub A is that mu is something other than 8.9. We don't know if it's more or less. We just think it's something other than that. What is mu? That would be the population mean for the species. I'm just copying this last sentence. For the species that left these bones. It's actually the population's mean length to width ratio. Length to width ratio. Okay. Awesome. State, plan, do, conclude. So let's get to our plan. What am I planning? Hopefully it's safe to assume n equal 41. The population is at least as large as 10 times the sample size. So 41 times 10 is 410, and we assume the population is much bigger than that. I'd assume there's more than 410 of these types of bones on the planet or the world or whatever. So what else? Well, we need n to be greater than or equal to 30 based on the central limit theorem, and it is. Last time I checked, 41 is greater than or equal to 30. So we can use normal, we can assume approximately normal or use normality. Okay, what's this? What's the last one? Random. The problem states the sample was random. Okay, so down to the do. Well, we said my test statistic. My test statistic is t x bar minus mu over s sub x over n, square root of n. So let's fill that in. So what is our x bar? Our x bar is, scroll down, 9.26878. 9.26, all round to 9. Minus mu, 8.9. all over. What was my standard deviation? It says 1.199. 1.199 all over the square root of 41. Then it calculated the t for me. The t was 1.97. 1.97. Okay, so using the table B, and the calculator has its own table B, it comes up with a degree of freedom of 4 and a p-value, oh, close but no cigar. So we come up with a p-value of 0.055783. So we are to perform this at alpha 0.05. So if that is the case, when we do our summary here, since alpha is greater than 0.05, because 0.056, or however you want to round that, is greater than this, we fail to reject the null. We do not, or we don't have sufficient evidence to support H sub A. What is H sub A? To support that the bone ratio differs from 8.9, right? We don't have sufficient evidence to show that it differs from that. So we're stuck with that. Thanks for joining us. Happy studying. Good luck.